Okay, I think we're recording now. So, all right, let's see. These are the homework problems, and this is the first one. And so we're talking about this firm manufacturing these two products. And what I'm going to do, let me see if I can actually write on here. Okay, so it says each of which must be processed through departments 1 and 2. Product A requires 3 hours per unit in department 1 and 4 hours in department 2, and the profit margin is $5 for product A. And product B requires 2 hours in department 1 and 6 hours in department 2, and the profit margin is $6. The weekly capacity for department 1 is 120 hours, and the weekly labor capacity for department 2 is 260. We want to determine the number of units to produce of each product to maximize profit. So there isn't specifically a question the way I usually like to see these problems, but it is an implied question. So you could say, instead of saying we want to determine, we could cross that out and say, what is, right? I can't write very well with this, but say, what is the number of units to produce of each product to maximize profit? So there's a question mark. All right. So if we make that a what is question, then it really points us to what we're going to make as the unknown. So that's the first thing you want to do, is figure out what your unknowns are. Now, maybe by reading this, and maybe you already kind of have a feeling, but just because of the way the problem is set up to be fairly transparent. But let's go ahead and switch to the whiteboard. And can you tell me, Andrew, what you think X would be and what Y would be? What are the two unknown quantities in this that this question is sort of asking for, that we need to find to maximize the profit?
Like the number, hold on, wait, sorry.
So right here at the very end, it says, what is the, I changed it to what is, I changed it to a question. What is the number of units to produce of each product to maximize profit? So right there, it's telling you what to start with. You said you wanted to know how to start the problem.
Yeah.
So that's how you start. You kind of find what your goal is, and then this kind of tells you the number of units to produce of each product. Okay, so that's the way to find your path through this forest so you don't get lost, is that's where we're going to start. So if we look at that, the number of units to produce of each product. So we go back and we're like, well, what are they talking about products? Well, up here we saw that it referred to product A and product B. So when I did an example in class, I was talking, remember, about wine racks, deluxe and standard. And then I also talked about an example about a rocking chair and a table. So here we're kind of being a little more vague. We're just saying product A and product B. Is that clear so far?
Yeah.
Okay, how about Sean, Melissa, and Gianna? Do you guys see that? Are you clear on that piece?
Yeah.
Okay, so I'm going to switch gears here, and can you see my screen now, this whiteboard? Is it full size?
Yeah.
It's good, you guys can see it? Okay, hold on, let me switch mine to speaker view.
I can't really see it. It's like the small square.
Yeah, so I think you have some options where you can switch to
I can only see the problems. Is that
you can only see you can't see this whiteboard?
Yeah, I only can see the
Oh, you meant
problems
behind
too.
you. I thought you pulled up one next to the I thought you pulled up one on the screen. Never mind.
That's okay, no problem. So there's I'm not 100% sure. It seems like every time I get on Zoom, they change the choices. But there's one that says, there should be one that says show small active speaker video. I don't know. I don't know if you can see me, but I'm hoping you can see this whiteboard. So if you guys can't see it, then you gotta let me know. But basically what I'm going to do for problem 1 is I'm going to start out and say, well, X is going to be, and I'm going to go back to that problem and I'm going to say, oh, they want to know the number of units. Remember, I always want this to be a quantity. So this is going to be the number of units.
If anyone's still seeing it small, you can just pin her little thing and it'll bring it up bigger. I don't know if that makes sense. It'll say like pin.
Thanks. It worked great.
Good. Okay, so now you can see it says X equals the number of units of product A, and we're going to let Y equal the number of units of product B. Okay, so that's where you start. You always want to start with your unknowns. And the reason for that is once you've got the unknowns identified, they're going to be what you're going to put in your table of information. So that's the table of info. I'm going to say that. And table of info. And some people skip this step, but I think it's easier to do these problems, especially if you're starting out doing them with this table of info, because it's what I call the pseudo math. It's halfway between the word problem and the math problem. So it's the bridge. It kind of walks you over. And so I told you, once you figured out the unknowns, then we're going to put those as the column, the 2 middle columns. And to the left of that, we'll put relevant info. And to the right of it, we'll put constraint. Now, we may not fill this whole table with 2 rows of data. We want at least 2 rows of data and possibly a 3rd row if we have a really easier problem. So let's just see how this one shakes out. I'm going to go back now to reading the problem. Can you guys see the problem now? Can you see the problem?
Yeah.
You can. Okay. All right. So now we're going to go back and we're going to be trying to look for this relevant info. So as I read through this, I says, okay, we got 2 products and they have to go through departments 1 and 2. So I'm kind of thinking in my head, this departments 1 and 2 are relevant info, because to make this product, we're going to have to use both departments. So now I'm going to go to product A and it says it requires 3 hours per unit in department 1. So let me go ahead and go back, and can you see my whiteboard now? Okay, I'm going to assume you can. If not, someone yell. Okay, so I'm going to say department 1 is the first one we're talking about. And it said product A requires 3 hours in department 1. So X is the number of units of product A. So I'm going to say 3 hours for every unit of X of product A. And then I keep reading and it says, and 4 hours per unit in department 2. So we're still talking about X, which is product A. Sometimes you can even give yourself a little reminder, like in parentheses, I'm going to write product A and product B above the X and Y. Sometimes I've used A and B for the variable names, but then that sometimes confuses people because we have to graph this. So let's just stick with X and Y. So now I'm going to write department 2, and it's telling me information in that first sentence about product A. So everything's going to go in this first column because it's all about product A. So it's saying that product A requires 3 hours per unit in department 1 and 4 hours per unit in department 2. Okay. And then it says, all right, so now I want to go back here. And I'm looking and it says, okay, so we did this. Then it says the profit margin. Hold on, let me try that again. Hard to draw straight on here. The profit margin for product A is $5 per unit. Okay, you guys see that? So that has nothing to do with Department 1 and Department 2. That's more relevant information. So let's put that in our table. Okay, so over here, I'm going to say profit. That's the next thing in this word problem that I happen to hit. And it says $5 per unit. Hello, Ben. We are working on problem 1 in the homework.
Perfect. That's the only one I had a question on.
Okay. And product B requires 2 hours. So now we're just kind of reading through the problem and trying to fill in the table.
Can I just ask one quick question? Oh, question.
Absolutely. You can ask more than one. You can ask many. That's why I'm here.
I think I only have one. For the table, should we put department 1 and 2 at top or product A or B?
Okay, so we just went over that, but I'm going to review it again. Can you see the word problem right now?
Yeah.
Okay, see kind of where the question is. And what I said, oh, apologies. What I said was in this particular problem, the question was not really with a question mark, but we can change we want to determine to what is the number
okay.
of units to produce of each product to maximize profit and add a question. So right off of here, we read off in order to figure out how to maximize profits, we need to know the number of units to produce of each product. And that's your path through the forest. That's how you figure out what to call your variables, because it's going to tell you right here. It's the number of units to produce of each product. And that's why if you look on this whiteboard, you can see the whiteboard, right?
Yeah.
The very first thing I did was use that last sentence that was really where the question is to set up X is the number of units of product A and Y is the number of units of product B. And that's how you know which one goes into your columns. And I actually did give a little cheat by calling them X and Y, but in parentheses, I write product A and product B. Okay. So
I couldn't really hear your audio, but I understand. I think I got it.
is my audio kind of glitchy?
It cut out for a second, but I got the gist. That's the only question I had.
Okay.
All right, thank you.
Sure. So, yeah, so now we're going through and we're reading this sentence and we're reading the word problem. So we already got through the first part where it talks about product A is 3 hours in department 1 and 4 hours in department 2 and has a $5 profit. Now we're going to read what the information is regarding product B. So now I'm going to look at that again. And here I see that product B requires 2 hours per unit in department 1 and 6 hours per unit in department 2. So we got a 2 and a 6 hours. So let's go in and put that in our table. So we got 2 hours in department 1 and 6 hours in department 2. Okay, now let's read what comes in the next sentence. The next sentence says that the profit margin for product B is $6 per unit. So I'm just kind of going sentence by sentence and putting it into this table when I can. Now that's not going to be the case in all of these problems, but it's often the case, and it's definitely like the first pass of what you want to do, and you want to get as much as you can on this table as possible. So let's add this now, this last bit about the profit margin for product B being $6. All right, so I'm going to come in here, I'm going to say $6 for the profit. All right, and we already know because of the way the problem was set up initially that it's the profit that we want to maximize. So that means this is going to be our objective function. Is going to be based on that last row of data. All right, now let's go back and read that problem again and see what other information there is, because we really need some information on constraints. Okay, so let's put constraints in orange because they're constraints, so they're kind of like slow down. Okay, so then we have the weekly labor capacity for Department 1 is 120 hours. That means that we can't go for over 120 hours in Department 1. There aren't enough workers doing hours of work to be able to do more than 120 hours. So for that, let's go ahead and on the whiteboard, we're going to say Department 1 has to be less than or equal to 120. And we are all in hours here. So everything is in hours. So we definitely want everything in the same units. So now I'm going to look at that problem again, and I see that the weekly labor capacity for Department 2 is 260 hours. So that means that's the most they can work. That's less than or equal to 260. Okay. So let me just pause here. Is everybody kind of comfortable, or do you have any questions with how I took that information and put it into this table?
I joined a little late, like I just joined the Zoom, but I'm a little confused on how to set up the table. Would you be able to go over that a little quickly?
Sure. Okay.
Thank you.
So I'm going to erase everything quickly off of the initial problem. So we're looking at homework 1. And the first thing I said was, let me see if I have text here. Yeah, so we're going to kind of modify and recognize that the last part here was actually meant to be the problem. So another way that we could say is, oops, hold on. What is, right? So what is the number of units produced for each product to maximize profit? So that's probably the key thing, is that you're going to want to recognize, even if it's not written with a question mark, that that's really the question. And so from that, we identify and I'm going to go quickly through this, but you go identify from there, if you can see my whiteboard, that X is the number of units of product A and Y is the number of units of product B, because the question that we just read was, what is the number of units to produce of each product? So that's how you figure out what to make your variables X and Y. And then those variables X and Y, those become your column headings for this table. So that's why you have to first figure out what your unknowns are. And those come again from the question about what you're going to maximize or minimize. And all these problems are maximizing profits. So they're always about what are the things that will be, that you need to know the quantity of to maximize profit. So that I just cheat and write product A and product B above the variables X and Y. So I got it clear. Then what I did is I read through the problem, and I'll go ahead and read it now. It says product A, which is X, requires 3 hours per unit in Department 1. So I wrote Department 1. And 4 hours per unit in Department 2, and has a profit margin of $5. So that's why after I went back and reread the problem, and I started adding, every sentence became like information to this table. So now I went in and I continued to read this problem. I saw that product B requires 2 hours in Department 1 and 6 hours in Department 2 and has a profit margin of $6. So that's how I set up everything in this table, except for the constraint part. Then what I realized was that the problem initially asked me to maximize the profit. So I added the word maximize here. And as soon as I add the word maximize, that means this information here is going to be where I'm going to build my objective function from. So you're always trying to build an objective function from your unknowns. And then you're also going to try to build constraints. We want to turn this into a math problem. And that's what a linear problem requires. It requires an objective function and constraints. So that's what you're shooting for here. Okay, so now we go back and we need these constraints, and they weren't here before. And they're in the word problem where we read that the weekly labor capacity for Department 1 is 120 hours. So labor capacity means that's the most hours of work we can get from Department 1. So hence that implies a less than or equal to. So the labor capacity is less than or equal to 120 hours. I mean, the most we could do is 120. So how much labor we use cannot exceed that. And for Department 2, the word problem tells us that it's less than or equal to 260 hours. Okay. All right. So let me ask again. And this is why we're here. So, don't be shy. Is everybody good now with how we took this word problem and made it into this pseudo math problem so far?
Yes.
Everyone's good? Or are we stuck at all in any of the steps? Are we good? Sounds like we're good, right? Okay. So now we're going to take this table and we want to turn it into math. So to turn it into math, the first thing I'm going to do is use the objective function. And I'm going to, this is profit. So I'm going to say profit equals, and I'm going to use these numbers as the coefficients of the variables up at the top. So profit is 5x plus 6y. Okay. And we want to maximize this. Okay. So now I'm going to take the two other rows of information in this table, and I'm going to turn those into inequalities. So again, let me see if I can get another color up here. I'm going to use the 3 and the 2 and the less than or equal to give me my first constraint. So my first constraint is going to be 3 times x plus 2 times y has to be less than or equal to 120. And then I'm going to go to my second row, and I'm going to use the 4 and the 6 and the less than or equal to 260 to come up with the second inequality. So 4x plus 6y is less than or equal to 260. Then I'm going to ask myself, does it make sense in this problem to have negatives? So let me ask you that. Does it make sense to have negative product A made and negative product B made?
No.
Right, no, right? That's clear, right? So that means x has to be greater than or equal to 0 and y has to be greater than or equal to 0. And these are what we call the non-negative constraints. I would say in like 98% of problems in linear programming, you get them. So these are the non-negative constraints. There are exceptions. But they're pretty rare. So this means that when we try to graph that feasible region S, that this has to be in quadrant 1. In other words, the upper right corner of the coordinate plane. All right, so given that, we're now ready to solve the math problem part of this. So I'm going to erase the word problem part because I need more space. Is that okay? I kind of forgot to check in. You guys good with me erasing that, or?
Yeah, I'm good.
You're
Yeah,
good with
I'm
how I
good.
did that?
Yeah.
Okay. All right, because now it's just a math problem. All right, so let's solve this math problem. I'm going to see if I can squeeze in a little bit down here so we can do our graph up top. So over here I have this first one. Oh, this was the second one. So we have 2 lines. And so for the first line, I need to find the x and the y intercepts. So, and I also need to know what side to shade on. And that's why I use a combination of method 2 and method 1. So what I mean by that is I want to put this in the y equals mx plus b form, and then I'm going to go back and get the x intercept. So I see this 3x here, and I want to bring it over to the other side. So I'm going to say 2y is less than or equal to negative 3x plus 120. And then I'm going to divide the coefficient in front, the 2 out, so I can get just y is less than or equal to -3/2 x plus 60. Because remember, I want to divide every single term by 2 on the right. So I know in 113, we are writing out all those steps in between. Are you guys okay with what I just did, or do you want me to fill in anything? Are you okay? You guys okay with this? Okay. Now, what automatic, nobody said no. And nobody said yes either, though. But okay, I'm going to take silence as a yes. So this automatically right here, right? This is like mx plus b, right? So the 60 is the y-intercept. And we're going to shade all the y's that satisfy this inequality have to be less than or equal to this line over here. And we know automatically by looking at this that 0, 60 is the y-intercept. And then I want to go back and I want to get the x-intercept, and I'm going to use the original equation for that. But I'm going to set y equal to 0. Because to get the x-intercept, I set y equal to 0. So I say 3x plus 2 times 0 is 0, has to equal 120. So that goes away. So dividing both sides by 3, I get that x equals 40. So I'm going to write it as an ordered pair so I don't get it mixed up. So I'm going to say 40, 0. All right. I'm hearing something. Anyway, sorry about that. Okay. Okay. Hi, Abby. I just saw your chat. Yes, we are working on problem 1 from the homework. Okay. So I got 2 numbers, right? Maybe I'll try to circle them in green so you guys can see them. Okay. So looks like I'm going to come over here and do, so let me just stop right there. Is it clear what I was trying to do here? Is there any confusion? Does anyone want to talk about this a little bit? So you're clear, right? You take that first inequality and you're going to solve it graphically. So in order to solve it graphically, we need to get the x and the y-intercepts. And that's what we did. And we also need to know what side to shade. And so because I put it in this form, I know I'm going to shade below that line. All right, so if I wanted to, let me start I guess I'll start it over here. I'm going to draw this first quadrant here. And I'm going to just draw line 1. And so I have 0, 60, and 40, 0. So let's say that's 60. And over here is 40. And notice I'm not that picky about like counting this all out. What really matters is like which one goes higher and lower between the 2 lines. But okay, I'm going to connect now these 2 dots, these 2 points. And I'm just going to draw only in the first quadrant, right? Because that's the only place, because we have these non-negative constraints. They're also requiring that x has to be greater than or equal to 0. So x has to be to the right of the axis, y-axis, and y has to be greater than or equal to 0. So we have to be above the x-axis. All right, and we're going to be shading below that. So far, this is what we know of our feasible region, but we got to add the second constraint in. I'm not shading that in, but I just wanted, since we're doing this workshop, I wanted to go ahead and make sure there's no confusion. Okay, so now I'm going to use inequality number 2 to add the second line. So I have 4x plus 6y. And I'm going to put a little 1 here. Sometimes when you have like multiple lines, it helps to label them. Like that example I did in class where we had like 5 lines or 4 lines or something. Okay, 4x plus 6y is less than or equal to 260. All right, so the first thing I'm going to do is subtract the 4x from both sides. So I get that 6y is less than or equal to negative 4x plus 260. And then I got to divide both sides by 6. right? And so y is less than or equal to -4/6. And you could, the slope, I don't know if you've noticed, we haven't been using the slope that much. So it's okay to just maybe leave it as -4/6, or you can just say, oh, okay, I know that's -2/3 x. And then we got 260 divided by 6, and I don't think I have my calculator handy, so I need someone to tell me. Maybe I can someone pull up their calculator?
Wait, where did you get 260 divided by 6?
Oh, okay, so let me back up. So we got this is the original inequality. And I subtracted the 4x from both sides so that I got -4x plus 260. Then I wanted to divide out the coefficient in front of the y, which was 6. So I have to divide both sides by 6, and I have to distribute that 6 amongst every term in the numerator.
What's the
So-
original inequality? Sorry.
4x plus 6y is less than or equal to 260.
And then wouldn't if you're solving for y equals 0, wouldn't that just be 4 divided by
Oh,
260?
so I didn't
260
do y
divided by
equals
4?
0. Oh, yeah, that's the next step. The first step is I want to convert the line into y equals mx plus b form. So I'm trying to get mx plus b form. So this is the mx, and I need the b.
Okay.
Yeah, because what I'm trying to do is automatically get the y-intercept and automatically figure out what side I'm going to shade. So this is that method 2 approach. So I just need to get 260 divided by 6, which I think is not,
It's 43.33.
yeah, okay, so it's 43.33, so it's 43 1/3. Is that what you guys got? Yes, okay, 0.333, okay. So this is automatically now going to tell me that that y-intercept is 0 and 43 1/3. Everybody good with that? Dave, you too?
I'm still, I think I just did something wrong in my math, so I'm just looking it over right now.
Okay, because what I'm getting ready to do is now I'm going to find that x-intercept by setting y equal to 0. Oops, let me switch back to black. What I'm going to do is I'm going to now go in and I'm going to take that original equation and I'm going to say this is 4x plus 6 times 0 is equal to 260. So now I'm going to divide both sides by 4. And that's going to give me that x because I have y equals 0 and x is equal to 260 divided by 4, which is
65.
65? Yep. All right, so now I have 65. So now I have the point 65, 0. So I have these 2 points, 0 and 43 1/3 and 65, 0. So I'm going to put those in here. So I'm going to say this is where 43 1/3 is. And 65 is going to be, if this one's below, then this one usually is bigger because you usually get a point of intersection. That doesn't always happen, but it's generally the case. So I'm just going to say that's there, and then I'm going to connect the dots there. All right, so now if I want to color underneath this line, right? So we're going to shade below. That's what I figured out by putting this in the y less than or equal to -2/3 x plus 43 1/3 part. So that shows me that my feasible region is the overlap of that shaded region. So this is the space in here, and I'm going to label now the corners. So I have an A, which is that origin. I have this one over here, which I'm going to label as B. I have this point of intersection C, and I have this one D. So this is where you're supposed to ask questions if you didn't follow or you're not sure how I did any of this so far.
I have a quick question.
Go ahead.
Like, for 43 and 1/3, could you round it up to 44? Or
No, um, we don't really know that much about product A and product B. Now, yesterday I was talking about tables and chairs. So, and we also don't know if that's going to be the optimal solution. So before we talk about rounding and whether we need to, that you want to first get the solution and then decide. So let's say we go through all this and we figure out that, yeah, we get a maximum profit at 43 1/3. Well, then we might want to say, well, what do we do? Because if they were rocking chairs and tables, we'd have to make a whole product. Product B sounds like we would need a whole one. So if we needed that, then we would probably round down. We'd go to 43 so that we can satisfy our constraints. Because if we round up, what's going to happen is we might exceed our constraints. And so we wouldn't really be able to deliver on that. Does that make sense?
yeah, it does. Thank you.
Sure. Okay. So let's keep going for right now anyway. Okay. So I'm going to need more space here. So I'm going to have to erase some stuff. So I'm going to erase this part right here. All right. So let's put the corners in. So we got the corners. We got X, we have Y, and we have P, which actually is right here, 5X plus 2Y. So that kind of worked out. All right, so the first corner A, usually you can ignore A because it's so if you have the origin, I mean, you can ignore it because it's 0, 0. And profit is 5 times 0 plus 6 times 0 is just 0. Okay, B, what's B? What are the coordinates of B? It's on the x-axis. So x is 40, and it's the x-intercept, so it's 40, 0. Is everybody good with that? Do I need to talk about that a little bit more at all? Okay.
I'm
So
good.
now we're gonna- Question? Go ahead.
No, sorry, I was just saying I was good. My bad.
Oh, okay, no problem. Okay, so now we're going to go and we're going to use this function on the x and the y quantities. So it's 5 times 40 plus 6 times 0, which is 0. So 5 times 40 is 200. Now we're going to go to C. C, we don't know what it is. So we need to find this point of intersection. So to find C, I'm going to go back and I'm going to use the original two equations. So I'm going to use 4x plus 6y equals 200. That was the second one. And the first one was 3x plus 2y equals 120. All right, so here we need to figure out how we're going to solve for x and y for that point of intersection. So I'm looking at 4 and the 3, and that's a pain to deal with. And then I got a 6 and a 2. So it seems like the easiest thing is to multiply the bottom equation by -3 so I can get rid of the y. Does that make sense? Kind of the way I'm thinking about that. Another way you could do this, by the way, since you already did all this work, but this is a nasty fraction. Never mind. Whenever I don't like to deal with nasty fractions, so let's not do that. I was going to say you could set them equal to each other, but that's just going to be a pain in this case. So let's skip that. Okay.
Wait, I'm sorry. Could you repeat what you said about those two equations that you just wrote on the top right?
These two right here. So if you were to go back and look at the earlier work, this was the original two constraints, right? That's lines 1 and line 2. And we want to figure out that point of intersection because that's the corner C and we need to know what that is. So I'm just writing them as dropping the inequality, make them equalities. So I put equals and we have to solve it. And I'm saying, well, I'm going to use elimination And if I look at the coefficients 4 and 3, right, I need to multiply both equations by something, or I have to somehow end up with the coefficients being opposite. So when I add them together, when the variable goes away. So what I'm choosing to do is I'm going to multiply the second equation by -3. And the reason I'm choosing -3 is because I see this 6y above it. And I know that if I multiply 2 times -3, I'll have the -6y and then it'll cancel. Is that clear?
Yeah, it is. Thank you.
Sure. Okay, so now let's go ahead and write this down. This is going to be -9x. -3 times 2 is -6y. And -3 times 120 is -360, I think. Let me confirm that. It's getting dark here. I might have to turn on some lights. Okay, so now I'm going to add the second one to it, right? So I'm going to add the 4x plus 6y equals 200. I'm going to do elimination. I'm going to have -5x is equal to -360 plus 200. So that's -160. And if I divide both sides by -5, I'm going to get that x is equal to 160 divided by 5, right? And so that's going to be 35. Is anyone checking I'm doing math in my head, so, and I'm tired. So hopefully you're checking on your calculator. But I get x equals 35. Has anyone confirmed that? Okay. I'm going to now go back and plug that 35 up back into either equation. Either one will work. And I'm going to choose the lower one. So I have 3 times 35. Maybe I'll come below, so we'll have a little more room. 3 times 35 plus 2y equals 120. Right, so this is the substitution step to get to the second variable. So 2 times 35 is going to give me 70.
Wait, I have a question.
Sure.
For all the way in the top right, isn't it 4x plus 6y equals 260?
Oh my goodness, it is. I'm so glad you realized that. Yeah. So okay, so then that should have been,
And then
My-
I got x equals 20.
oh, okay. So then we're going to put 260 here. And so when we subtract it out, we end up with -100, right?
Yeah.
And when you divide that by -5, you get 20. Yes. Very good. Okay, so then 3 times 20 is 60. All right, now we're matching, right? Thank you. That's the problem with this whiteboard. It's big, but it's not big enough. All right, so okay. And I make mistakes, so it's harder to see it, but okay, thank you for catching that. I appreciate that. So we got 2y now is equal to 120 minus 60 from both sides, right? Which is 60. And then we divide both sides by 2, and we get that y equals 30. So this point here, the point C is 30 and, 20, 30, right? So that point C is 20, 30, right? We got an x equals 20 and a y equals 30. So it's 20, 30. So we're going to put that into the profit, and it's 5 times 20 plus 6 times 30. All right, so let me try this. So we got 5 times 20 plus 6 times 30. So I get 280. All right, then we got D. And D was the 0 and 43 1/3. So it's 5 times 0 plus 6 times 43 1/3. And that's going to be, so the way I do this on my calculator, just so you know, is I say 1 divided by 3 and plus 43. And then I say times, what was that? 6. So that comes out to 260. All right. Now I look at these numbers and I'm like, okay, which one is the maximum? Maximum is the 280, right? And again, it is really, I wish the people who put these problems together would not do this, but it's really a coincidence that it's on the point of intersection. It doesn't always land on the point of intersection. But in this case, it is that point of intersection 2030. So our answer is that the profit is a maximum of $280 when 20 units of product A and 30 units, sorry about my handwriting, of product B are made and sold. Okay. So I kind of have to go, but I'm willing to stick around and maybe set up another one or address any other questions you guys might have.
Would you be able to go over how you found the point C again? I kind of missed a little bit of that.
Sure. So can you guys still see this clearly? Because it's getting dark here. Should I turn on a light or can you see it?
It's a little blurry. I mean, I can't really see it.
You can't really see it? Okay. Great. All right. Can you see it better now a little bit? Does that help?
It might not be the lighting. It just might be like how far how far it is from the camera.
All right. Let me see what I can do about that. I don't know if this is
Just
going to
a
help.
little blurry.
Is it blurry? Okay. How's that? Does that help?
I mean, yeah, that definitely makes it clear.
Good.
Um,
Okay. Let me talk you
yeah.
through it then. All right. So I took my 2 equations. So, I took my 2 equations. And you guys are clear on where those 2 equations came from, right? The original constraints, but now instead of being inequalities, they're equalities because they're the equations for these lines. Okay? And then
Wait.
this is the process of elimination.
Do you have 5x plus 6y equals something?
No.
Okay,
5x,
sorry.
5x plus 6y is the profit, the equation for profit that we want to maximize.
So do you have that above above
that- All we're trying to do up here is get the feasible region, and that only comes from the constraints. It comes from the inequality. So
Okay.
this here is the S, right? That's the feasible region S. And that feasible region S comes from the 2 constraints. We're finding out what side of that lines we're going to be shading, and we figure out the corners of the overlap of the shaded regions. So then what I did is I took those 2, and if you look in the notes from what we did earlier, because I had to erase it but this is the first of the constraints, and then this is the second of the constraints. Is that what's causing the issue? Is you don't know where those equations are coming from, or is it solving by elimination?
I'm not sure which equations to choose. To like subtract from each other.
Okay. So I'm going to erase some stuff because I think it'll make things hopefully a little bit clearer. Okay. All right. I think hopefully this will work. Okay. So there's always going to be a function. In this case, it's P and it equals something. Okay. Then there's always going to be some inequalities. So they're going to have a less than or equal to, greater than or equal to, whatever. There's like stuff here with X's and Y's. All right. There's at least two of them. All right. Whatever those two are, we drop these inequalities, make them equals, and that's how we get the point of intersection over here. We want to solve this system of inequalities using elimination or whatever method you like to use. And that's all I was doing up here is I took the initial two constraints that came off that original table of information. We got those constraints. I dropped the inequalities. I wrote them as equal signs. And then I'm solving them using elimination here. Does that help at all? Trying to
Yeah, that just explained it because now I see that after you like solve that part, you got X equals 20, you put X equals 20 into the second equation below.
Yes.
That did make sense.
Okay, good. Okay, great, good. Okay, so yeah, so then my whole goal was to know what to fill in here and here. And then once I had all these corners identified, then I had to evaluate P at each one of these. And then after I evaluate P at all of these corners, I went back in and I said, okay, which one of these numbers is maximizing this? Okay.
Can you lower a tiny bit to the bottom of the chart, please?
Yeah, and for some reason, let me see, sorry about that. Oh, you want to see actually how I wrote out the solution. Profit is a max of 280 when 20 units of product A and 30 units of product B are made and sold.
I got it. Thank you.
Okay, you get kind of how you write it up.
I'm still getting it.
Say that again.
Oh, I'm still writing it down.
Okay. And these problems become very much.
I got it. Thank you.
Oh, you're welcome. These problems become very much like a repeat. So when you get into the second problem, like I said, I got to go pretty soon, but what I am willing to at least walk you through the big picture on the second problem, unless there's a different problem you want me to walk through instead. I'm going to try to put my camera back for right now. Let's see how that works. All right, let me turn on the light too. Let me see if I can get this kind of set up. I think that's going to help everybody. All right, do you guys want? Let me go back to sharing my screen. All right. Can you see my screen?
You're kind of cutting out. I can't really hear what you're saying.
Oh, I'm cutting out.
Yeah,
Now
you're
it's
cutting
fine.
in
I'm
and
sorry.
out,
Can you
but
hear me
it's
better?
better now.
Yeah, no, it's fine.
I did switch to Xfinity not too long ago, and I'm not very happy with their internet, but we'll see. All right. Sorry about that. So let me erase this because I can't scroll otherwise. All right. Can you, do you have out of the next three problems, is there one in particular that you wanted me to go through to kind of help set up? I actually think number 3 might be important. How about I go ahead and work with you guys on setting up number 3? And I'll let you do all the math and work it all out, but let's work on setting it up. What do you think? Does that one sound good?
Yeah, that's good.
Sounds good to me.
Okay. All right. So let's go ahead and read it and see what it says. So it says a company produces 2 bikes, a mountain bike and a road bike. And it takes 3 hours to assemble a mountain bike and 4 hours to assemble a road bike. The total time available to assemble bikes is 60 hours. And the company wants to have at least twice as many mountain bikes as road bikes to sell. The company makes a profit of 200 per road bike and 100 per mountain bike. Now here comes the question. How many of each bike should be made to maximize profit? So that's the first thing. We got how many of each bike, right? So could someone tell me what X and Y should be?
X would be mountain bikes and then, or like number of mountain bikes and then Y number of road bikes.
That's right, perfect. All right, so let me write that down. X equals number of mountain bikes. And Y is going to be number of road bikes. And I'll share my screen in a minute, but for right now, hopefully you wrote that down too, right? Because we figured out what X and Y is. This is the key first step. All right, so now we're going to make a table, right? And we're going to add X and Y columns to our table. And right above the X, I'm going to put a little MTN. And right above the Y, I'm going to write road so I don't mix it up. And now I'm making my table. And I'm going to write relevant info in the first column. And I'm going to write constraint in the 4th column. So let me share real quick, make sure you match me. Let's see if we match at this point. Okay. Can you guys see that okay? Do you match that? Do I need to take my camera up close or can you see it?
Like, that's fine.
Yeah, so you guys match. Okay. All right, so now let's go back to reading this problem and filling out this table. Okay. So now we go back and it says, okay, a company produces mountain bikes and road bikes. Okay, it takes 3 hours to assemble a mountain bike and 4 hours to assemble a road bike. So we're talking about time to assemble, right? And right away, we're told that the total time to assemble bikes in general is 60 hours. So we're giving the constraint right there. So let's go ahead and put assemble or hours to assemble or hours to, yeah, or assembly or whatever you want to say in your, and how you want to label this. But we're going to, in that first row of data, we're going to put under the X, what are we going to put? What number do we put under the X?
3,
That's right. And what do we put under the Y?
4,
4. And then what's the constraint?
it has to be
Less than or equal to 60.
Yeah, less than or equal to 60. Okay, great. Okay, you guys see how it's starting to be like the same pattern a little bit? All right, but now we're going to get to this next thing where it says, and this is where this one gets a little bit tricky. It says the company wants to have at least twice as many mountain bikes. Whoops. Sorry about that. As road bikes. Let me try that again. Okay. The company wants to have at least twice as many mountain bikes as road bikes. All right, so sometimes you don't have information that's going to go into a table as a relevant information comment like that. Instead, you might have a relationship between the variables, and that's what happens in this case. So here we see that the company wants to have at least twice as many mountain bikes as road bikes. So what does it want to have more of? So
Or
sometimes,
mountain bikes.
yeah, it wants to have mountain bikes, and mountain bikes is X. So it wants to have at least twice as many mountain bikes as road bikes. So that means it wants mountain bikes to be at greater than or equal to twice the number of road bikes. Now that inequality, writing that inequality may require that you write it wrong and then reread it and be like, okay, no, that's not what it's saying. So that part I recognize does take a little bit of practice, but you basically want to identify, well, which one has to be bigger and by how much? So this one is saying the company wants to have at least twice as many mountain bikes. So that's why you're like, oh, it wants more mountain bikes. So the X has to be greater than the other one. And by at least twice as many. Does that make sense? You might have to stop and think about that a little, but that's how you get that second constraint, because we need one constraint per variable. Since we have two variables, X and Y, we need two constraints. So the first constraint is coming from this line of relevant information. The second constraint is going to be coming from this. Now you're like, well, I don't understand. That doesn't really look like the other constraints that we've seen so far. But if I were to subtract 2y from both sides, it does, because now I have x minus 2y is greater than or equal to 0. And this becomes the inequality in the format you're normally used to seeing. All right, so let's go back to reading this problem and seeing how to continue to fill out this table. All right, so now we're back here and we read the next line that the company makes a profit of $200 on the road bike and $100 per mountain bike. So we're just going to add a row of profit to our table of information. So I'm going to call this profit. And I'm going to copy in that it's 200 per road bike. So the 200 actually goes over here. And it is, what did it say? 100 for the mountain bikes. That's why it helps to kind of put these little reminders on top. Okay, and this is what we're going to maximize. So because this is what we're going to maximize, this is the objective function. So when I want to write the linear program, remember I need an objective function and I need the constraints. So the next thing I want to ask myself as I put this together, I'm going to write the linear program down here. Now that this is sort of my pseudo math, like scratch pad where I'm trying to sort it all out. So my linear program is officially that I want to maximize the profit, which is going to be 100x plus the 200y, subject to, and this is where I'm going to write my constraints. So for me, the first constraint is this 3x plus the 4y has to be less than or equal to 60. So I'm just reading off this first row of data. So this is going to be 3x plus 4y is less than or equal to 60. And then the second constraint is coming from here, which I'm going to rewrite in a way that you're more comfortable with. So I'm just writing it as x minus 2y has to be greater than or equal to 0. So that's this version. Okay, and then I know that I can't make negative bikes. So I also have the non-negative constraints. Okay, so now it became a math problem. And now you're going to solve it by graphing these lines and shading in the first quadrant. What is the feasible region? Identifying the corners, and then for the x and y from each corner, plugging it into the profit function and seeing which is the biggest number. Okay, so that's the big picture of how to get that one done. Well, I hope that helped. I need to go. Unfortunately, I had a lot of computer problems today and I got a lot of work ahead of me. So now that my computer's working, the good thing is at least I can get it done. All right, do you guys have any other questions or anything before we say goodbye?
How would we solve the second constraint? Because how do we get x as a number? Because wouldn't it, like, in the end, would it be x divided by 2?
Oh, I see. Okay. Yes, it would. So let's look at that. If I take this equation, x is greater than or equal to 2y, I can also write it as 2y is less than or equal to x, right? I wrote the same thing. I just put the 2y on the left side. Is that okay?
Yeah.
Okay, now I divide both sides by 2, like you said, right? And I get y is less than or equal to a half x. Right?
Okay.
But it's really a half x plus 0, right? So this line has a x and y intercept as 0, 0, and has a slope. Now this one will actually going to use the slope to graph it because the slope is a half. So when I go to graph it, I'm going to go through the origin at 0, 0, and I'm going to go up 1 and over 2. And I'm going to just draw that line. And when I go to shade it, I see that my y is less than that line. So it's going to have to be shading. Sorry, I should have done a different color. I got to shade below that line because that's what this less than or equal to part tells me, right? Did that help?
Yeah, that did. Thank you.
Yeah. So
Thank
that's,
you.
yeah, don't get thrown off by weird things. Just always try to get it into y equals mx plus b form and be like, okay, x divided by 2, well, that's just a half times 2.
Thank you so much.
You're very
I
welcome.
appreciate it.
Thank
Thank
you.
you, Professor.
All right. See you guys tomorrow. Take care.
Thank you.
Have a good night.
Bye.